Okay, so for example, actually let me give the actual explanation first before I do the example. So the composition of inverse functions. Okay, so for any one-to-one function, don't need. Say we'll call it f, some function f and some function g. I guess you can say that instead of making it more complicated. Instead of saying g equals f inverse, we'll just say and f inverse. So used to writing g, that just makes it worse. Okay, the composite of f and f inverse is going to equal x, and the composite of f inverse and f of x is going to equal x. Okay, so if they truly are inverses of each other, they should cancel each other out when you have the composite. Okay, so we'll give you an example of that one. Show whether f of x equals 4x plus 2 and f inverse of x equals x minus 2 over 4 are inverses or not. Well, we know they are because we just solved for them. But we're going to show the actual steps to prove that they're inverses, assuming that we didn't already solve for them. Okay, so we just have to f of f inverse of x. Remember, that's just f of f inverse of x. Uh-oh, forgot my 1. Okay, so we're going right back to our composition that we did earlier. The only difference now, instead of two different ones, we're just getting the composition of a function and its inverse. Okay, so since f of x is equal to 4x plus 2, f of f inverse of x is equal to 4 times the inverse plus 2. Or you can just plug it right on in. So 4 times x minus 2 over 4 plus 2. Oh, bring that up a little bit. Okay. So you can see here the two 4s will cancel each other out. So here you have x minus 2 plus 2. These two will cancel out, so you're just left with x. So we know that the composite of f and f inverse equals x, because that's what we just solved for. So now we just have to switch them up and see if we get x again. Okay, so f inverse of f of x, remember that's just f inverse of f of x. Okay. So since we know that f inverse of x is equal to x minus 2 over 4, f inverse of f of x is going to equal, instead of x minus 2, f of x minus 2 over 4. So if we just plug in that f of x, we have f inverse of f of x. So our f of x is 4x plus 2. So we have 4x plus 2 minus 2 over 4. Okay, so that's just equal to 4x plus 2 minus 2. Those two will cancel out. So we end up with 4x over 4, which is just x. So we know that f inverse of f of x equals x. Okay. So we know it's both 1-to-1, and they are inverses of each other. Yep. All right. So any questions on that one? All right. Make sure one's okay. Okay, so let's say, for example, here, we're using the table below, which will be there in a few seconds. Evaluate f of g of 3 and g of f of 3. Okay, so if we have our table here, so you have your x, f of x, and g of x. Say x is 1, 2, 3, and 4. You line that up. So you have 6, 8, 2, and 1, and 3, 5, 2, and 7. Okay. So what this is really saying is f of 1 is equal to 6, f of 2 is equal to 8, f of 3 is equal to 2, f of 4 is equal to 1. Same thing with g. G of 1 is equal to 3, g of 2 is equal to 5, and so forth and so on. Okay. So first, to find f of g of 3, first thing we have to do is find g of 3. Okay. So we can see here that when x is equal to 3, g of 3 is equal to 2. Okay. So that means that f of g of 3 becomes f of g of 2. I mean f of 2. Okay. So when x is equal to 2, f of x is equal to 8. Okay. So that means that f of g of 3 is actually equal to 8. So move that up a little bit. Did that make sense? All right. I'll give you a little bit to start on the other half of that. So you start on g of f of 3. composites, you want to go from the inside out. Anyone stuck? All right, let's start on this one. Okay, so the first thing you want to do, like I said, starting from the inside out, is to find f of 3. Okay, so bring that back down a little bit. Okay, so we know when x is equal to 3. Okay, so when x is equal to 3, your f of 3 is 2. Okay, so we can now replace g of f of 3 with g of 2. Yep. Oh, sorry about that. Okay. Any questions on that part? Okay, so now we have our x value of 2. When x is equal to 2, g of 2, we go down, our x is equal to 2, so g of 2 is equal to 5. So that means our g of f3 is equal to 5. So it kind of bounces around a little bit once you get to charts and all that other stuff, but hopefully that made a little bit of sense. Okay. Any questions on either one? All right. I'll leave that up there for a few seconds. All right. Okay, so let's say for this example, we want to find the domain. Of f of g, where f of x is equal to 5 over x minus 1, and g of x is equal to 4 over 3x minus 2. Okay, so we know what we're looking for. Our f of g, which if we just rewrite it, is f of g of x, which is just f of g of x. Okay, so a lot of times this is a whole lot easier to visualize than that one. Okay, so if we have our f of g of x, so f of x, we know that's 5 over x minus 1. So that means our f of g of x is equal to 5 over g of x minus 1, which just becomes 5 over 4 divided by 3x minus 2. Oh, where'd I get that one? Oh, minus 1. Sorry about that. Mixing up my problems. There we go. Okay. So this tells us two things, really. Kind of the same idea, but two different portions of it. We already know a denominator can never equal 0. Okay. Since a denominator can never equal 0, we know that this denominator can't equal 0. So 3x minus 2 can equal 0. And we also know this entire denominator can equal 0. So 4 over 3x minus 2 minus 1 can equal 0. So all we have to do is find the values of x that it can't equal, and we'll find our domain. Okay, so if 3x minus 2 can't equal 0, that means that 3x can equal 2 if you add 2 to both sides. So that means that x can't equal 2/3. And we also know that if 4 divided by 3x minus 2 minus 1 can't equal 0, if we add 1 to both sides, we know that 4 over 3x minus 2 can't equal 1. Okay, so if we multiply both sides by 3x minus 2, those two would cancel out. So you have 4 can't equal 3x minus 2. And now you just solve for x. So if we add 2 to both sides, we know 3x can't equal 6, which tells us x can't equal 2. Okay. So any questions on that so far? Okay. So once we find the values that it can equal, me personally, I love the number line. Use these values to find the domain. Okay, because remember, the domain are all the x values that you can equal. So these just tell us the two that you can't. You can do anything else. You can have x equal any other number except those two. So me, by liking the number line because it kind of gives me a visual of what I'm trying to do, So if you know it can't equal 2/3 and it can't equal 2, that means on this portion of the number line, it can be anything from negative infinity to 2/3. And since it can't equal 2/3, we're going to use the parentheses. It can be anything in between them. So it can be anything from 2/3 to 2. Just can't equal those actual values. And it can be anything in this interval from 2 to infinity. Okay, so our domain can be anything in any of those intervals except those two values. Okay, so our domain is going to be from negative infinity to 2/3, or from 2/3 to 2, or in the interval from 2 to infinity. Okay. So remember, once you solve for those two, you're almost done. You just have that one last step. Okay. Any questions on this one? All right, I'll view that up for a second. Make sure everyone's done. All right. So let's say, for example, find the domain of the composite function say f of g of x, where f of x is equal to square root of x plus 2, and g of x is equal to the square root of 3 minus x. Okay. So we already know that the radicand cannot, especially when you're dealing with real numbers, we're not dealing with complex numbers just yet, but we know that the radicand cannot be negative for a square root. Okay, and the radicand is just the number up underneath. That's just a fancy name for number underneath the bracket. So we know that the square root of 3 minus x cannot be less than 0. Okay. So if we square both sides, we have 3 minus x cannot be less than 0. So if we add x to both sides, it just means that 3 cannot be less than x, or if you switch them around, x cannot be greater than 3. Okay, so we solved one. Now for the other one, let's say f of x equals square root of x plus 2. We have to first find the composite. So f of g of x is equal to the square root of g of x plus 2, which we know is equal to, bring that up some, the square root of the square root of 3 minus x. plus 2. Okay, so that's your f of g of x. Okay, so we know just for this one, that can't be anything greater than 3. Okay. But we know here, since this will never be 0, because at some point this would have to be bigger than negative 2 for that to be 0. I mean, smaller than negative 2 for that to be 0, and this will never be negative. So since that will never be negative, we don't have to worry about the domain as far as the f of x. Does that make sense? No, okay. So now we know that f of g of x has the domain of x as long as it doesn't go past 3. Okay, so if we go back to our old faithful number line, and we have 3 there, we know that x can't be, don't need that one, can't be greater than 3. It can be equal to 3 because square root of 0 is just 0, and that's fine. Okay, it just can't equal 3. I mean, it can't be greater than 3. Okay, so it means you can have anything from negative infinity all the way to 3, even including 3. Okay, so anything to the left is okay. So that means your domain is actually from negative infinity to 3. Okay, so any questions on that one? All right. Okay. Oh, anyone still writing?